Hello, this is Mrs. Taylor, and I'm going to walk you through how to evaluate inverse trig functions. So first thing we have to discuss is the domain and range. You have to keep that in mind with the inverse trig functions. So if you look for arc sine, which is the same thing as inverse sine, basically your domain is from -1 to 1. So when you evaluate, your x values have to be between -1 and 1. And then your range is from -pi/2 to pi/2. So when we look at the unit circle, for arc sine, our range is restricted to the right side of the unit circle. So from -pi/2, which is here, all the way to pi/2. So arc sine would be the right side of your unit circle when you're talking about range. And so your domain is between -1 and 1. So when you put in your angle measure, you can't put in 11 pi/6. You have to put in -pi/6 because that's between -1 and 1. 11 pi/6 is greater than 1. So just keep that in mind when you're working with arc sine. When looking at arc cosine, same domain, -1 to 1, but our range is from 0 to pi. So when I'm looking at arc cosine on the unit circle, instead of being the right half of the unit circle, it's the top half. It's from 0 to pi, so from here all the way to there. So you can't evaluate arc cosine for anything at the bottom half of the unit circle. And so if you tried to put in 7 pi/6 into your calculator for arc cosine, you would get an error message. It would tell you the domain is incorrect. And then for arc tangent, the domain is -infinity to infinity, so it doesn't matter what x value you put in there, but again it's restricted to -pi/2 to pi/2 on the unit circle. So that again would be the right side. And so arc sine and arc tangent are both restricted to the right side of the unit circle, and arc cosine is the top half. Now the rest of these functions, arc cotangent, arc secant, and arc cosecant, they all have restrictions as well. However, in this course we're just focusing on arc sine, arc cosine, and arc tangent, or inverse sine, inverse cosine, and inverse tangent. What I would do is I would pause this video and go ahead and write down the domain and range of these three functions. So now let's talk about how to actually evaluate these. So when I'm asked to evaluate arc sine of -1/2, what I'm really trying to find is sine of what angle would give me -1/2. So it would look like this. And so one tool that will really help me with wrapping my brain around these is the unit circle. And when I look at the unit circle, I'm looking for where y is -1/2, because remember sine and y are partners on the unit circle. And when I look at the unit circle, I see that y is -1/2 here and here. So -1/2 here and here. And the trick is with inverse trig functions is you have to remember domain and range. So remember, arc sine's domain and range is restricted to the right half of the unit circle. So I would not use this value for arc sine. And then also remember the domain is from -1 to 1. So even though this radian measure is 11 pi/6, that's not within that domain. So I have to think of it in the context of -1 to 1. So instead of saying that 11 pi/6 is my radian measure, I would say start at 0, move down, and that would be negative pi over 6, and that would fit between negative 1 and 1. So when evaluating, my answer would be negative pi over 6. That is within the domain and range restrictions of arc sine. So now let's move to arc cosine. And this is asking arc cosine of 0 is what? So again, let's think of it as cosine of what angle would give me 0. And so I go to my unit circle and use the restrictions given to try to evaluate. So cosine of what equals 0. And remember, cosine is linked with your x values. And so cosine was the function that was restricted to the top half of the unit circle. And the only place where x equals 0 for the top half is here at pi over 2. And arc cosine's domain restrictions were from negative 1 to 1. Pi over 2 is within that restriction, so that would be my answer. Arc cosine of 0 would equal pi over 2. Alright, so our next one's a little more challenging, arc tangent. And remember, tangent is sine over cosine, so we're working with fractions here. And arc tangent of square root of 3, you have to think, okay, square root of 3, so that would be sine over cosine. So which y value over which x value would reduce down to square root of 3. And this may be one you just want to memorize these relationships. It might make your life a lot easier. Of course, you can always work it out if you have to. So we have tangent of what value, what radian measure will equal square root of 3. So really we're looking at sine of what value over cosine of what value equals square root of 3. And remember, this has to be the same radian measure here. And so one thing that helps before you even look at the unit circle is to think through what would reduce to square root of 3. And so one thing, again, to have memorized is what that relationship would be. And it's square root of 3 over 2 over 1/2. If you think through it, dividing by 1/2 is the same thing as multiplying by 2. That would get rid of this denominator of 2, and you'd be left with square root of 3 over 2. So what I'm looking for is where y is square root of 3 over 2, because that's sine, and where cosine is 1/2. And when I look at my unit circle, y is square root of 3 over 2 here and here. And remember, we're looking at arc tangent. So for tangent, we're restricted to the right half of the unit circle. So that would take this one away, and we'd be left with this. And I have my y value is square root of 3 over 2, my x value is 1/2, and that's at pi over 3. Remember, tangent's domain is not restricted, so it really doesn't matter as far as does the radian measure fall between negative 1 and 1. That's not a restriction for tangent. The only restriction is that we had to use the right half of the unit circle. So our answer would be pi over 3. So arc tangent of square root of 3 equals pi over 3. The last one is the easiest. It's arc sine of 0.3. Anytime you see an inverse trig function and they're trying to get you to evaluate it at a decimal that's not easily converted to a fraction, or it's not a fraction we're familiar with, like 1/2. Typically those are problems that you would put in your calculator. So just a quick reminder of how to do that. Remember, you want to be in radian mode, because in our class we only work in radians. So if you go to mode, make sure you're in radian mode. And then once you've established that, you just punch in arc sine, which is the same thing as inverse sine, which is here in blue above the sine button. So you hit second sine. That little -1 does not indicate 1 over sine. Remember, it's just the indicator that this is inverse. And then 0.3, hit enter, and it gives you the decimal answer. And in our class, we round to 3 decimal places, and you can truncate, which means you just cut it off at the third number, or you can round. So your answer would be 0.304 or 0.305 if you rounded. And that's how you would evaluate your inverse trig functions. Just a couple of quick things before I end the video. First, your calculator doesn't always want to evaluate these trig functions that are the cos, so cosecant, cotangent, and secant. So you may want to write these down just if you have a homework assignment or a classwork assignment where you're having to evaluate these in your calculator. These are some conversions you can use to get your calculator to evaluate. And then also what I would like for you to do is complete page 379, number 5 through 12 to turn in on Monday. And then if you want to practice your trig derivatives, your inverse trig derivatives, you can do that on page 379, number 43 through 60.